Good afternoon, dear students. In the last video presentation, we discussed about various methods of chlorination. What is chlorination? What are the various methods? What are the list of methods? Then we discussed in detail about plain chlorination, pre-chlorination, ammonia chlorine treatment and breakpoint chlorination. Now let us continue with the methods of chlorination. The next method which we are going to study here is superchlorination. Okay. What is superchlorination? The application of chlorine beyond the state of breakpoint is known as superchlorination. Now you know what is breakpoint chlorination. So application of chlorine beyond the state of too much above breakpoint is known as superchlorination. The residual chlorine content after breakpoint chlorination may be 0.5 to 2 ppm. Okay. So superchlorination is adding excess of chlorine beyond breakpoint so that the residual is 0.5 to 2 ppm of chlorine. Now, what is the use of adding so much of chlorine? Addition of greatly elevated level of chlorine above chlorine demand produces quick disinfection. It produces quick disinfection, destroys originally present in water and those odors which result from addition of small amount of chlorine. When this method is adopted, only short contact time is required. But because we have added too much of chlorine. So why do we add too much of chlorine? Because it produces quick disinfection, destroys the odor originally present as well as those which result from adding small amount of chlorine, and the contact time is very short. But when you add chlorine in excess or when you perform superchlorination, too much of residual chlorine is present, and hence to remove the excess of chlorine, superchlorination has to be followed by addition of dechlorinating agent. Okay. So in order to remove excess chlorine, the water is to be treated with dechlorinating agents like sodium thiosulfate, sodium sulfite, sodium bisulfate and SO2 gas. Okay. So we can add any of the dechlorinating agent like sodium thiosulfate or sodium sulfite or sodium bisulfate or SO2 gas. So superchlorination has to be followed by addition of dechlorinating agent to remove excess of chlorine. Now the next method is double chlorination. Okay. When chlorine is added to raw water at more than 1 point, okay, when chlorine is added to raw water at more than 1 point, it is known as double chlorination. When raw water is highly contaminated and contain large amount of bacteria, it becomes necessary to adopt pre-chlorination and post-chlorination. That means we first, because the water is highly contaminated, contain large amount of bacteria, we perform pre-chlorination. We add chlorine initially. Then go for treatment of water by say filtration method. And then after filtration, we again chlorinate the water. That is called as pre-chlorination and post-chlorination. Because the water was highly contaminated with bacteria and contained large amount of say turbidity or color compounds or organic compound, and that is why we had to perform chlorination twice at 2 points. Okay, especially pre-chlorination before filtration and all, and post-chlorination after filtration treatment. Such method is called as double chlorination. Okay, so the advantage of double chlorination are same as that of pre-chlorination and post-chlorination for such waters like which contain highly contaminated and contain large amount of bacteria. In addition, the second unit of chlorination plant serves as standby unit and load of impurities of filter is greatly reduced. Okay, so we go for pre-chlorination, then post-chlorination, because of which the water which was highly contaminated may now become absolutely clean and clear. Okay. Now the next method is chlorine dioxide treatment. The chemical composition of chlorine dioxide is ClO2 and it is found to be more effective in removal of bacteria than chlorine. Okay, alone. It also removes, so it is chlorine dioxide ClO2 is more effective in removing bacteria than chlorine. It also removes taste, odor present in water. It is also useful for water containing significant amount of ammonia because it does not form combined residuals with ammonia. Okay, so ClO2 treatment has many advantages. That is, it removes bacteria better than chlorine. removes odor, removes taste. It has no effect. The method is very effective and significant also, even if ammonia is present in water. But the ClO2 gas is very unstable and it has to be used immediately after it has been produced. It can be produced by passing chlorine gas through sodium chloride. Sodium chloride. NaClO2 combines with chlorine gas, that is sodium chloride combines with chlorine gas to form ClO2. Okay, and you can see the reaction, ClO2 is formed. But ClO2, because it is unstable, it has to be produced and immediately used. The dose of chlorine dioxide varies from 0.5 to 1.5 ppm and its action is unaffected by pH values between the range of 6 to 10. So it's one of the best methods. Chlorine dioxide is one of the best thing, but hence it is useful for high alkaline water also. Okay, water with high alkalinity can be effectively treated with chlorine dioxide because it is very effective in the range of pH from 6 to 10. Dose 0.5 to 1.5 ppm. But the most important drawback, or you can say restriction, of using chlorine dioxide is it has to be prepared in situ on time when it is required, and number 2, it is costly. The cost of chlorine dioxide gas prevents its adoption on a large scale. Otherwise, chlorine dioxide is one of the best methods of treatment of water, that is chlorination. Okay, so that is all about various methods or forms of chlorination.